Exits will be at the front of the building and at the front.
Remember,
Yes.
if they do ask you something you don't know, just say, you know, I'm not really sure about that, and then we'll fill in for you.
Okay.
Well,
Cool.
it'll be over before you know it. Most people think, oh, half an hour on TV, how am I going to get through this? And 2 minutes later, we're done,
Yeah.
and oh, that was great.
Good. Well,
That's what I'm counting on.
1 minute.
For the past 4 years, students and faculty at Manchester University have led a collaborative, community-wide effort to protect and enhance the water resources of the Middle Eel River watershed in Wabash and Miami counties. And tonight we'll find out what's being learned from this work and what it can mean for conservation practices in Northeast Indiana and around the state. And we have several guests with us. Dr. Terri Sweeten is Associate Professor of Biology and Director of Environmental Studies at Manchester University. With him is Terri, who is the coordinator for the Middle Eel River Watershed Initiative. And with them are Manchester University students Breegan Andersen and Trisha McClain. They are also watershed technicians. And we'll invite you to join the conversation as well. There's room for everybody. Just call in your questions and comments to the number that you see on the screen. Welcome to Primetime 39. I'm Bruce Haines, and welcome again to you all as well.
Thank you.
Thank you, Bruce.
Thank you.
And from my left, this is Terri, Jerry, Trisha, and Breegan.
Right.
And again, we'd like to know who you are too as we're going along. And we'll start the program by perhaps asking for a little more definition on that word watershed. We'll say this multiple times through the next 30 minutes. Terri, what am I talking about?
Sure. A watershed is simply an area of land that drains to a single point along a river or stream or into a lake. They are defined by topography. So in other words, political boundaries don't matter. When rain falls, it doesn't know if it falls in Wabash County or Allen County. It's going to follow a topographical flow to the lowest point. So everybody lives in a watershed. Everybody has an impact on the watershed that they live in. And yeah.
Well, so a picture that can also help compare with 1,000 words. Let's take a look at picture B here, because this is also the one where if you're traveling on the Pennsylvania Turnpike, for example, I will see the sign that says entering the Chesapeake Bay watershed, and that's right around Somerset. And then on practically near Downingtown, you know, way east of Harrisburg, I see the sign that says I am now leaving the Chesapeake Bay watershed. This is a large chunk of territory. There's the Watershed Initiative logo that we're focusing on. Let's go to picture B, because this is the one where, whether it's the Turnpike or anywhere here in Indiana, there's a funnel effect of some kind going on?
Right, right. And it's important to understand that smaller watersheds can be nested within larger watersheds. So say you have the Mississippi River Basin watershed is a huge watershed that covers about 40% of the United States. But you can have every river and lake and stream has its own smaller watersheds within that area. Does that help?
Yeah, well,
Okay.
in fact, and Jerry, let me ask you to pick up on this. We hear in weather forecasts, they'll talk about, well, the weather's going to be changing for us in the Ohio River Valley.
Yes, right.
I think, well,
sure.
the Ohio River is way south of here.
Yeah,
Why
sure.
are they putting me into that?
Sure. And, you know, perhaps this is a good place too, Bruce, to mention that there's actually a continental divide in watersheds between the Eel and Fort Wayne.
Right.
So the water in Fort Wayne drains into Lake Erie. The water in the Eel drains to the Wabash River, and then on to the Ohio, and then on to the Mississippi, and then it's the Gulf. So while there's no big mountain range, it's just a bump in the road. Clearly, it's a continental divide.
And the Eel River in this case is, while we talk of this as the middle eel, this is a river that actually you shared with me actually has its beginnings in Allen County.
It does, it does. And so the east.
It's about, what, 3 or 4 miles north of Fort Wayne.
That's correct.
Where the actual beginnings of the Eel River is.
Sure
So
is.
The Eel runs about 110 miles from up here north of Fort Wayne all the way to Logansport, and then that's where it joins the Wabash.
And I suppose within cities and towns you have the drainage ditches as part of a watershed, or you have water runoff and spillways as a part of an industrial parks watershed in a sense. For Trisha and for Breegan, what is it about watersheds that draws so much attention to it? What is the fascination or the collection of data that can come out of a watershed that can be instructive, whether I'm involved in farming or just living nearby?
Well, like you said, that the water, that everyone's within a watershed, so that means that the area within that certain watershed, every rainfall or any water that falls within that particular boundary is all going to fall in the same like water source. So there's an interest because it affects the water quality of that water. So all of the water that's running at the top of the mountain that you saw in that picture B, when it rolls all through the residential areas, agricultural farms, so you're running through your herbicides that you put on your lawn, or also the herbicides that they put on the agricultural field, all run together and mix together and fall into that main water source like the Eel River.
So, Breegan, is a watershed then an example of, say, a micro-environment, you know, a reflection perhaps? Some people say you learn a lot about a neighborhood on trash day. I mean, do we learn a lot about our environment by studying watersheds?
Yeah, I mean, you can learn a lot by just studying like the smaller watersheds within this bigger Mississippi River Basin or Ohio River Basin. So, I mean, we're just studying a little part of the Eel River or Beargrass or Pawpaw watershed. So it's kind of just a small part, and we're just getting to the beginning of it.
Let's take a look, in fact, at picture 3, which, in fact, will perhaps provide other context for where in Indiana we are exactly.
Right. Well, the Middle Eel River Initiative focuses on a 30-mile stretch of river from North Manchester to Mexico, Indiana. It's kind of hard to see, I think, on that graphic, but so that's why it's called the Middle Eel River Watershed, because it sits right in the middle. And so right now we are about an hour south of where we begin our work, is about an hour south of where we're sitting right now. And the watershed itself, it has it in 10-digit HUCs, it looks like on here, which is just a hydrologic unit code. That area that we focus on is about 169,000 acres. So even though we think of it as being the Middle Eel and only being one part of that entire basin, it's still a large area. And what we would like to see eventually with our work is that we spread out throughout this entire Eel River watershed and work throughout the entire watershed.
The tributaries, the feeders.
Right. And so maybe this is a good place too to point out that when Terri mentioned this hydrologic unit code, new term, that's sort of like a house address. So those of us who study watersheds, we give them specific numbers that help us identify the size, the relative size, and the location. So by looking at these specific numbers that we call hydrologic unit codes, which I'm not sure are on our maps and perhaps not really important here, for us, people who study these sort of things, that helps us just as an identifier in terms of the types of research that we might do.
I know the old expression, and we see monitoring locations, and there is a backstory to that. I'm reminded that the old adage is you never step into the same river twice, or you never put your foot in the same stream twice. Yeah. You have had about 4 years now with the same part of the Eel River. Before we perhaps revealed from all of you what types of things you have been discovering along the way, it might be good to hit rewind a little bit and go back to not only 2009, but perhaps maybe, what, 2006, 2007?
Yeah, we've actually been doing some research on the eel in and around North Manchester for several years, and through a gift we were able to buy some equipment that we needed, a field truck, an electrofishing boat, some analytical equipment to do water chemistry work, which allowed us then to compete for a larger grant to do more intensive work to take a look at that interaction between land use in these two sub-watersheds and the types of water quality that's what's going down the stream, just to provide baseline information, as well as looking at the fish community and the mussels to get more of a holistic view of what might be taking place. And so to do that, there's some serious sort of scientific research that has to take place. We want to make sure that any data that we collect is accurate.
We have a sampling of some of this now, and as the university has been then working with this equipment to close the loop, you had the opportunity to connect at the federal level with an extension of work that really helps bring the kind of credibility and application to it beyond just, say, a discrete project, right?
We couldn't do this without partners.
No.
We absolutely could not. They're critical. But I will tell you that maybe perhaps before we get into that those specific partners, that our goals are, really we have two primary goals. And for me as an educator, being at the university, our primary goal is to provide good, solid, experiential learning, relevant research that is compatible with academics that take place in the classroom. In other words, we want students to come in contact with real world, I want to call them issues, real world, trying to figure out how it works. And then our second goal is, is to bring this money to help demonstrate that land use and water quality are not mutually exclusive. For example, clearly agriculture is the largest land use within the Eel River watershed. We don't point fingers at anybody. We don't say you're doing a good job. We don't say you're doing a bad job. We say we want to work with every land use and work and try to figure out a way that we can make, or at least find out what the water quality is like and then make it better. And so our grants not only come with monitoring money, but they also come, and this is what Terri administers, comes with cost share money. We will have spent nearly $3 million in the Middle Eel River, actually more than that, right? Probably closer to $4 million.
To 4.
With agricultural producers, helping them to explore and sort of finance best management practices that producers can use to improve their productivity and improve water quality.
So you, as students, realize this is not just a study that lives in isolation, bound for dust on a shelf somewhere. Tell me, for each of you, and Trisha, let me start with you, how your contact with this program came to be. What kind of work have you been doing?
Well, you mean just with the internship,
Sure.
what kind of work I was doing?
Yeah.
At the beginning of the summer, I was basically doing water samples, like collection, and I would collect all these water samples after a rain event or every day, because we took water samples every 4 hours for our particular project. And then we would determine the chemistry components of that sample. So we would see how much nitrogen and phosphorus was in each sample, and also the total suspended sediment and how clear the water was, which we call NTUs. And then the second half of the project, I got to go electrofishing and shock a loose fish and then collect them and then try to identify them, because particular species indicate the type of water that you're dealing with, because some fish are tolerant to different types of levels of nutrients while others are less tolerant. So if you see something like a darter, which is kind of like a smaller fish that are normally found in riffles, then that means that the water quality is a little higher, unlike like a green sunfish, which is very tolerant.
Is this the kind of craft you would be out in as those things?
That's actually a electrofishing boat.
Okay.
So that's more for the larger areas.
Okay.
So when you're sampling the actual Eel River, that's when you're going to use that big toy. But for us, we just carried this like backpack type thing.
And we have something about that too. Look for the image about backpack shocking there below the diagram on Watershed. We can bring that up as we'll go to Breegan. We'll take a look at that photo. But Breegan, this is almost sounding like CSI Eel River. There are clues everywhere.
Yeah.
And you collect clues, and then you, what is it like then to try to analyze all of this and try to make something of these disparate pieces of data?
At first over the summer, I'm not going to lie, it was kind of just, oh, this is just a bunch of data and we're just putting it into Excel. and towards the end of the summer, we actually started putting that data to use. And like, we both did the same things. We worked together on the paired watershed study. So I did a lot of the electrofishing and like water chemistry, but we also focused on hydrology, which is the study of water movement. We looked at how fast the water was moving and like how much water is passing at that moment in time. So we used those to kind of predict like how much sediment is actually moving through the water per day from runoff. And we can do that, we can incorporate that into the nutrient loads too. So we were calculating numbers that are really important to putting these best management practices into play. So.
And I noticed too, we had this graph up earlier as well, was the map of the area under study, and that there were different monitoring places along the way, which again I assume the more you collect, the more holistic image of the river that you're getting. Right. As you're coordinating all this, then is it for you to then take this piece over here and bring this over here and assemble the parts?
Jerry actually is in charge of all the water quality monitoring, so
But Terri keeps us in line.
All right.
She keeps us on the straight and narrow.
She gets you to the bank and get you the clipboard and wishes you well.
So actually, we use a lot of technology. There's a lot of technology involved in what we do. Including computers that are in the field. We have automatic water samplers that we can program to collect a water sample from the river whenever we want it. We have them programmed to take a water sample every 6 hours. We have 3 of these stations. So every day during May and June, we're collecting quite a few water samples. And the reason we do that is the same. If you go outside and you take a picture of the weather and you say, this is what it's always like, we know that's not true. So if you just go out and randomly take a water sample from a stream and you say, this is what the stream is like, we also know that's not true because it changes every time it rains. The water's going to increase. And so by taking water samples with an automatic water sampler, now we can get a clearer picture of what happens when it rains relative to when it doesn't rain. And so that's where the technicians come into play. And if you look at picture number 7, you can actually see some examples of the types of water, what this does for us in terms of, there you go. So those are samples from our automatic water sampler. And it's wonderful. You don't have to be there. It'll even perk coffee for you before you get to the station to collect the water if you want.
You just signed out another volunteer.
But what this picture illustrates is, as you look at those bottles, on the left it's very clear. And now, if that would have been the moment in time you collected the water from the river and you said, aha, this is what it's like, we would say, well, that's pretty good. And what if you didn't collect the water sample for another month? But these water samples are taken every 6 hours. And so what happens is now we have a better picture of what happens when it rains. And you can clearly see the water turning muddy as a result.
And in that passage of time, not only in those samples collected, but over the years collected, how are we doing, Doctor, with our watersheds? What sort of takeaways are you sensing at the moment? And I'll ask all to participate on answering that one.
Well, let me say first that we're collecting really baseline information, and that what we need to know, here's the central question: can we improve land use? Can we improve how we farm? Can we improve how we live in towns, cities? And will we be able to detect that change in the water if we invest this money in trying to do a better job of land management? So that's the question. It's a difficult thing to answer. And by volume, and these are staggering numbers, by volume, soil in our water, mud in the water is the largest non-point source pollution we have. And if you go to slide number 5, you will see some of our data. So for example, if you look at these are nitrate, phosphorus, and sediment. These are the three big ones. These are the three big issues that we're dealing with. And if you look at sediment, 26,000 tons per year. That's a lot of soil. We call it Indiana's aquatic dust bowl.
And because it's very subtle, but it's also very consistent. It's still not showing any signs of slowing down.
Right, and what's so interesting about Breegan and Trisha's project is that they're looking at exactly what Jerry was just talking about. What they did this summer. Go ahead and talk about what you did this summer in comparison to what Jerry was talking about getting your baseline.
Watershed.
Yeah.
The hydrology was the main part of that. Like, we had to figure out the velocity of the water and like how much water is moving through, and then you could use equations through Excel and all that and plug in our calculations from like the data for the actual chemistry part of it, for the total phosphorus and the nitrate and the sediment, and you could incorporate those into the equations and actually calculate these numbers and predict and get a good question of how much is actually moving through the water at this point.
So this study happened this year, and now this fall, and over the next 2 or 3 years, however long we can afford to do it, we will try to partner with landowners to put these best management practices on the ground and continue the water quality monitoring and see if we're able to change that or improve that water quality. So that's exactly what Trisha and Breegan were doing this summer.
Exactly.
And we not only looked at the hydrology aspect, we also did the biotic aspects of the water, so that way we can tell how that water is affecting the aquatic communities that are residing in that water. Because that's why we electrofished, was basically to see, like I mentioned earlier, how many tolerant species are there, how many catfish, how many sunfish are there compared to the darters. So it gives us an accurate representation of how well that water quality is holding up compared to the amount of tons or loads that are entering into that water system.
As you're moving through this, what is it teaching you as you would like to take away something from this experience post-graduation?
Well, I guess it's kind of being I don't want to say like smacked in the face with real life, but like almost like that.
Gently nudged.
Yeah, nudged.
Yeah, there you go.
Because you go through classes and you go through lectures and you never really understand what it really what it means. It's just words to you until you actually get put in that situation. So until you actually experience for yourself, you really don't realize the importance of it all, like how it all connects, how much nature and society correlate with each other, and how important your professor's lectures that in the 8 o'clock morning class, you're like, I can barely pay attention, and like how much it's important and how exciting it is, because now you can really get excited. And I finally can see my future in that field and what to expect, because lectures can only say so much about really how you feel about the water, because not many people want to touch a fish. And then you really can learn, like, do I really like the slimy sensation, or am I just going to be a lab assistant?
Sort of the thing of, I can watch a video about parachuting, but
like, can you really
skydiving? But eventually, I'm going to have to get
take
in the
that plunge.
Breegan, how about you?
I was like, that's one of my favorite questions that people ask me is like, you actually enjoy playing with fish? Like, and I'm like, I do. Like, it kind of hits you like, I really do. Like, it's a nice experience to get to do all of the chemistry plus like the biology part of it and then the geology part. So you're kind of getting a feel for everything with doing these.
And over time, too, I'm noticing that the data and what is being learned is then being shared through the initiative. You have had information sessions for farmers and also over the cleanup day. Tell me a little bit about that as
we do a lot of education outreach, and one of those is that we have an annual public meeting, and unfortunately I don't have that date set, or I could give that to you today. But that is a meeting where we invite the public in and kind of share information that we've gained. We also try to get people out on the water in canoe floats and river cleanups that are a lot of fun, and and we've gotten tons of trash out of the river, and I know we're running short on time.
Well, I was seeing 10,000 pounds of metal recycled, 125 tires, and 2.5 dump trucks full of trash.
That was over 3 years in a 1 mile stretch of river. You can add 109 tires to that total from this year, and let me see if I can find my note here real quick. 13,000 pounds total for the metal that's come out of that 1 mile stretch of river. So it's absolutely unbelievable what we're able to get out of there.
We do this to ourselves, don't we?
We do this to ourselves, and we've done it historically. So before we had landfills, those were our disposal sites. So we're just trying to get as much out of there as we can, and we have a good time doing it. We really do.
Bruce, I don't know if there's a chance here. I really would like to mention our partners.
Please.
Because we cannot do what we do without them. The Natural Resources Conservation Service, which is part of the Department of Ag, the Soil and Water Conservation Districts in Miami and Wabash County, the Fish and Wildlife Service, the Ohio River Basin Fish Habitat Partnership Program, United States Geologic Survey, the Department of Natural Resources, and perhaps, maybe not more importantly, but very important, is the cooperation we have with producers, the farmers. There is not a farm we would not be welcome to go on and talk to farmers. And that's one of the really beautiful things about our project, is the collaboration across agencies and across people that we work with.
And we should also say very quickly that our funding comes from a Section 319 grant through the Indiana Department of Environmental Management.
Yeah,
so
good,
that's
thanks.
how we got started
Sure.
on that
Yep.
too. So.
And as folks are watching on air, you have created online a website where all of this can be seen and shared.
Yes.
What's the best way to get to that?
The best way to get to that, honestly, is just to type in Middle Eel River Watershed or just Middle Eel, and ours will be the first one and probably only one that will pop up that says Middle Eel River Initiative. Or you can visit the university's website and get to us through that website as well.
And just so that folks understand too, that good deeds do not always go unpunished; they go rewarded as well. That this work has now received an additional approval for 3 more years of funding. So congratulations!
Thank you.
Thank you.
Thank you.
Best wishes to you all. I want to be sure I have it all right, so I'm going to go backwards. We want to thank Breegan Andersen and Trisha McClain, and also Dr. Jerry Sweeten and Terri Michaelis very much for all being a part of tonight's program.
Thank you.
Thank you all
Thank you
very,
very
very much. And next week on Primetime 39, we'll have Mark Levy with us from the Cuesta Foundation, education and helping those attain education and graduate without as much debt and become an active part of the Northeast Indiana workforce. That's all a part of Primetime 39 1 week from tonight. For all of us with Primetime 39, I'm Bruce Haines. Thank you so much for watching. Have a good weekend.